then save the result into another file. So the C file name will be saved in the variable this. So the file is saved in this variable here over here, and the output should be saved in variable called C. So what you are required here is just um, run a compiler that will compile the C file and save the output to this variable C. So how do you do it? First of all, you connect your sandbox over here, and I believe you have cloned the repository to your machine. Connect the sandbox. Then, if you have not clone the repository by going to Git your GitHub repository and copy the code and paste over here and, clone it to your sandbox. So I believe you have cloned it anyway. So then the next step is to create this directory over here. Create the directory. Let's see into the repo ALX low level. Yeah, let's see into the repo. Then create the directory by typing mkdir, then the name of the directory, then click enter. File exists. So I have created it already. Then you can now seed into that directory. When you seed into the directory now, what you're required to have, remember this, you're required to have the readme file in your root, at the root of the repo containing description of the repository. Then you also have a readme file in the root folder of the project. So inside this inside this folder, you have to have a readme file. How do you create a readme file? You can just say echo, that's what you want to put there. This file will be hello world. I mean, yeah, hello world folder. Or let's just say yes. Then put it inside the file, a readme file .md. Readme file.md. Yeah, that's the file that is required over there. Then keep it there. So you are done with that. That was the next step. So the next step should be to create this file over here. How do you create this file? Same vi. I'm using a vim editor over here. So vi, then the name of the file you want to create. Programming, we use JCC compiler, and there's others compilers, but mostly use JCC. So use JCC. What you have to do is go to your sandbox, say let's see all the options that is available for GCC. Say man GCC on your sandbox and click enter. So this is all about JCC. You can read about them yourself. So I want to scroll down to all the options that you can use with JCC. So in C programming, there are various stages for running the C program. We have the processing stage, compilation stage, assembly stage, linking, and finally optimization, where it will be saved in a particular file. So these are the options you can use with JCC. When you say -s or -e to say where the JCC want is to stop. So what see here, if you only want some of the stages of compilation, you can use -x to tell the JCC where to start and where to stop. So one of the options you can use is -c, dash capital S, dash uppercase E, and the rest of them. This tells the compiler where exactly to stop in the stages of compilation. So if you use -c, compiler it will compile or assemble the source file, but do not link. So if you just want to compile and assemble the source file without linking, you use the option -c. The linking stage simply is not done. So you don't do, there's no linking stage. If you commit to not link it. So when you use -s, it will stop after the stage of compilation proper. So the assembly stage did not done. It will not assemble the code. It will only stop at the compilation stage. And when you use -e, it stop after processing stage. So it did not run the compiler proper. So at the output is in the form of processed source code, which is sent to the standard output. So, and if you use O file, the -o will place the output inside the file you name after -o. So the -o file, then it will process the code, compile it, and the rest of it. Then it will save it into this file. So that's how I'm going to use it. So from the question, we say you should just process it, yeah, yeah, through the processor. So you are going to store by E. What you are going to do is say, okay, let's move into the file vi0 this. So we are into the file now. What you have to do is you start writing a script. So you use a shebang. In every script you have a shebang, which is hash this slash bin slash bash. I used to call it shebang. So then the next will be JCC, then the option stopping at the process, that's E, then the file. Remember I said the file is going to be saved in this place. Then copy the file, copy the variable there and paste it over here. Then -o, that's the output, saving it into C. So I have a mistake over there. Move to the, it's not out, remove the @ sign. Yeah. Yeah, and that's it. That's all we have to do there. And this, we run the program. Can exit the editor. So we are done with that. So you can now you can push it to your repository. Say git add, then git commit. After the commit message, let's say first commit. Then yeah, then you can now say git push. So when you say git push, to push to your repository, and I don't want to push this again because I've done it before. So, but if you say, so if you run git push to push to your repository, then you can go to your checker, then click on your checker, and everything will check. Everything will be fine. That's just what you have to do there. Yeah. We move to the next. So here, say write a script that compiles a C file, but does not link. So it does not link. So it's the same thing with this, but this now it will not link. So what you have to do is just create a file. The file is compiler.1. So what I normally do, since since they are similar, I will just say, I will just copy the previous one, which is cp, then the file I want to copy, then the file I want to copy it to. So when I run this code now, it will now create this function and copy the content of this to this. So, and that's it. So, but I have created, let's do vi, then the name of the file. So we are into the file now. The same steps again. Shebang slash bash. Then JCC. We are stopping at the assembly, the compilation stage, which is C. We are not linking. So it has -C. We are not linking. Then the name of the file. Just copy it. I like copying it so I don't make mistake, because if you make a mistake, then your code will not run successfully. Yeah, that's all you have to do here. Just, you're not linking, you're not producing output. This is all you need to do over here, and that's done. You can now exit the editor, then you can say git add, git commit, then git add, git commit dash message, say task 1, and then the next thing is git push. Say git push, and you say git push, you then push it to your repository, and you are good to go. So that's all for the second one. Go back and run your checker. When you run your checker, you see it will be done. So the third one is write a script that generates the assembly code of a C code and save it in an output. Okay, the assembly code now. So the output file should be named the same as the C file, but the extension .s instead of .c. Okay, and example, if the C file is main.c, then the output file is main.s. So yeah, so what you have to do here is go to this, create this file, create the file vi2, then so we start by writing our shebang, then bin slash bash. Yeah, then start JCC. We are stopping at the assembly stage, which is dash uppercase E. Then the name of the file. So the name of the file over here is this. Then put it over there. Yeah, and that's all you have to do for this. Exit the editor, and yes, then do git push, git add, the same way, git add, git commit, and git push. Then go back and check your code by clicking the code checker. Yeah, the third one, and everything will pass. You can see it there, 100%. So the third one is write a script that compiles C file and create an executable name, C form. So what you have to do here is create the file, copy it, the file name, go to this, say vi the file name. So we start by the first is shebang /bin /bash. Then we start say JCC, then the file name this, then you post it -o, then where you want to save it to. Sorry. Write the script that compiles a C file and create an executable name with this. Okay, this is where you want to save it. Copy it, go to here, then paste it, and that's all for this. Then you exit our editor. Then you can now say git add git push, git add, git commit, and git push, and you are good to go.